And we'll get started today with section 9.5. Alright, and today we're going to introduce the sine and cosine ratios. And the sine and cosine ratios are trigonometric ratios. Oops. I'm just going to abbreviate that, trig ratios, for acute angles that involve the length of a leg and the hypotenuse of a right triangle. And so we'll just go ahead and I'll give you examples of each one of those. So let's look at sine and cosine here. I'll go ahead and highlight those so they stand out a little bit more. And if we draw that triangle that was multicolored like we did last time, so one leg is right there in blue, our other leg is going to be right here in green, and then our hypotenuse will be in red. Here we go. Label this guy A, B, and C as well. Oops. I don't know what I just did. You guys can't see it, but I just go away. There we go. I had a magnifying glass. I didn't even know that feature was there. All right, so there's A, there's B, and there's C. We have our hypotenuse right here. And then let's take a look particularly at angle A here. So if we look just at angle A, this green leg is going to be the leg that is opposite of angle A. And this blue leg is going to be the leg that is adjacent to angle A. And the sine and cosine is going to be defined as the following. So sine, which is abbreviated as sin, the sine of A is equal to the length of the leg opposite angle A divided by the length of the hypotenuse. Or in other words, opposite over hypotenuse. And if we were going to go ahead and color code that, that would be this green leg right here. That's what's opposite of A, so BC, divided by our hypotenuse, which is AB. And we could do the same thing with cosine now. So if we look at the cosine of A, abbreviated COS, that's going to be the length of the leg that is adjacent to angle A divided by the length of the hypotenuse. Or in other words, it's going to be the blue leg AC divided by the hypotenuse AB. And so now I'm going to give you a little trick to remember sine, cosine, and tangent. Remember we did tangent last time. And that is the phrase so katoa. Alright, that's how I remembered it. It's really easy to write, so katoa, and that is because the following. If we go ahead, put ka down here, toa down here, right? So is going to stand for sine, and then you're going to look at the next two letters, this O and this H. Alright? Sine is going to equal your opposite over your hypotenuse. Cosine is going to equal your adjacent over your hypotenuse, and tangent is going to equal your opposite over adjacent. So those are your different ratios. You have your opposite over hypotenuse, your adjacent over hypotenuse, and your opposite over adjacent. So that's a really useful phrase that I like to write down when I took exams on the top of my paper. Just SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. You'll use it all through trigonometry, I promise. And so now, let's go ahead and find some sine and cosine ratios. So let's go ahead and find on this triangle I will draw the sine of R, the sine of S, the cosine of R, and the cosine of S. So we're going to draw a triangle. Come on, connect. That's not. It said a triangle. There we go. Make it a right triangle. And this triangle is going to be called R, S, and T. T is going to be our right angle. And we're given the following lengths. The hypotenuse is equal to 65. RT is equal to 63. And ST is equal to 16. So let's go ahead. We're going to do our sine for R first. And so if we look at the sine of R, we got to go to the, well, if we look up here, sine is opposite over hypotenuse. So that's going to be opposite angle R divided by the hypotenuse. So if we go opposite of angle R, that is going to be 16. And then our hypotenuse is going to be equal to 65. And so that's 16 over 65, or approximately 0.2462. Likewise, we can do the cosine of R, and that is going to be equal to the adjacent leg over the hypotenuse. And the leg that is adjacent is the one that is right there that R is touching. So that's going to be 63, and that's going to be divided by our hypotenuse again, which is 65, or approximately 0.9692. So now we can do the same thing with angle S. So let's go ahead and take a look at the sine of angle S. Once again, that's going to be opposite leg over the hypotenuse, and the opposite leg is going to be 63, and the hypotenuse is going to be 65, and so that's going to be approximately equal to 0.9692, and the cosine of angle S is going to be the leg that is adjacent over the hypotenuse, so that is going to be 16 over 65, or approximately 0.2462. Now, what do you notice about the sine of R and the cosine of S, and the cosine of R and the sine of S? Well, in fact, they are equal. So that's a fun fact about cosine and sine, is notice that the sine of R is equal to the cosine of S, and the sine of S is equal to the cosine of R. And we're going to use this fact to, we're going to dive a little bit deeper into this fact, is what we're going to do. So let's go ahead and take a look at sine and cosine of complementary angles. And complementary angles, remember, are two angles that add up to 90 degrees. So as a reminder, complementary angles add to 90 degrees. All right, so simply put, the sine of an acute angle is equal to the cosine of its complement. And likewise, the cosine of an acute angle is equal to the sine of its complement. And so if we let angle A and B, let angle A and angle B be complements. Then the following is going to be true. The sine of A is going to equal the cosine of 90 degrees minus A, or in other words, the cosine of B. And the cosine of A is going to equal the sine of 90 degrees minus A, and since A and B are complements, the sine of B. And so now we can use this as an example, this formula as an example, to write the sine of 56 degrees in terms of cosine. And so the sine of 56 degrees is going to equal the cosine of, well, let's go ahead and look at this guy right up here. Oops, that was supposed to be a highlighter.
Charging battery.
Oops, forgot to unplug my headset, so you got to hear the lovely lady that talks in my ear when my headset's charging. Uh, if we look at this formula that I just highlighted in yellow, we're going to write the cosine of 90 degrees minus 56 degrees, or the cosine of 34. So let's go ahead and keep that in mind now. And use this to find the length of x and y using sine and cosine. And so our triangle is going to look like the following. There's our triangle. We have our right angle right here. We're given the length of the hypotenuse. That is going to be 14. And our x is right there, and our y is right there. And this angle down here is equal to 26 degrees. And so since we're only given this one angle to work with, we can use sine and cosine to find these different lengths. Because sine, remember, is going to be opposite over hypotenuse, and cosine is going to be adjacent over hypotenuse. So if we look at angle of 26 degrees right there, the sine of that angle 26 is going to equal the opposite over the hypotenuse. And the angle that is opposite is x, and the hypotenuse is 14. So now all we need to do is solve for x to find the length of x. And we do that by multiplying 14 on both sides. Those 14s will cancel, and you're going to get 14 multiplied by the sine of 26 is equal to x. And just like last time, you can find sine on your calculator, right? Even if you go to just Google and type in calculator, sine is there. And if you take 14 multiplied by the sine of 26, x is approximately going to be equal to 6.1. And if we do a similar thing for the cosine of 26, so remember cosine is equal to the adjacent over the hypotenuse. Well, the leg that's going to be adjacent is going to be y, and the hypotenuse is going to be equal to 14. And so once again, we're going to multiply both sides by 14. Those are going to cancel, and we're going to get 14 multiplied by the cosine of 26 is going to be equal to y. And just like last time, you can go to calculator on Google or take your calculator, turn your iPhone sideways, you'll see this cosine function. Take 14 multiplied by the cosine of 26, and you're going to get y is approximately equal to 12.6. Alright, so now we're going to dive a little bit deeper into some more common sine and cosine angles. So first, let's go ahead and find the sine of 45 degrees and the cosine of 45 degrees. So this would be like in a 45, 45, 90 right triangle, which I just drew here. And on a 45, 45, 90 right triangle, we know that if we make our side lengths both equal to 1, then our hypotenuse is equal to the square root of 2. All right, that's all the way back using the Pythagorean theorem. 1 squared plus 1 squared is 2. Take the square root, that is going to be the length of our hypotenuse. So the first thing I want you to notice is that 45 degrees is complementary to 45 degrees. And because of that fact, the sine of 45 is going to equal the cosine of 90 minus 45, which equals the cosine of 45. So the sine of 45 and the cosine of 45 are going to equal one another. And so the sine of 45 is going to equal the opposite leg over the hypotenuse, which is equal to 1 divided by the square root of 2, which equals the square root of 2 over 2, which is approximately equal to 0.7071. And just to reiterate this fact that the sine and cosine are equal to one another, the cosine of a 45-degree angle is equal to the adjacent leg over the hypotenuse. Well, the adjacent leg is going to be equal to 1 over the square root of 2, which is equal to, once again, 2 over square root or 2, which is approximately equal to 0.7071. Notice that I didn't really actually ever pick out an angle here because both of these are 45 degrees. So since those are both 45 degrees, we know that adjacent over hypotenuse is going to, equal each other. All right, let's go ahead and try to find now the sine of 30 degrees and the cosine of 30 degrees. Oops, let me redraw that here. So we're going to draw a 30, 60, 90 right triangle. There we go. And our right angle is going to be right there. Our 30 degrees is going to be down there. And then, of course, that's going to be 60 degrees up there. And if we make our shortest leg of this 30, 60, 90 equal to 1, then the hypotenuse is equal to twice the length of the shorter leg, and the longer leg is equal to the square root of 3 times the shorter leg. And so if we identify our angle that we want to use here, this 30-degree angle, the sine of 30 degrees is going to be equal to the opposite leg over the hypotenuse. And so the leg that is opposite is 1. The hypotenuse is equal to 2. So the sine of 30 is equal to 0.5. It's a pretty clean number, isn't it? All right, and because sine and cosine are complements, this is also, how did that make a triangle? Oh, this software is buggy sometimes. And because the sine of 30 degrees is complementary to 60 degrees, this is also equal to the cosine of 60 degrees. Because 30 and 60 are complements. And the cosine of 30 degrees is going to be equal to the adjacent leg over the hypotenuse. And so if we erase this line, the line that's going to be adjacent is going to be this root 3 right here. So that's going to be the square root of 3 divided by 2, which is approximately equal to 0.8660. And because 30 and 60s are complement, this is also equal to the sine of 60 degrees. All right, so I have one last example here for you. Nice real world type problem. Let's imagine we're standing somewhere. So we're going to stand on this ledge right here. Don't get too close, we don't want to fall. All right. Actually, imagine we're skiing. Okay, so here's our skier right here. We'll replace him with a snowboarder, even though I like skiing better. And we're going to go down this run, and this run's going to be a pretty straight run down there. And you're pretty cool, so you fly a drone out right here, right? So here's our drone, our quadcopter, and you want to film this entire run. And you have your drone hover at around 1,200 feet. And then you put your drone level to where you're at right now. And so that's going to create a right angle. And your drone is pretty smart, so it calculated that this was a 21-degree angle. So you're going to snowboard down this slope. You put a drone out 1,200 feet above this point, and you want to know how long this run is in feet, x feet. And so the sine is what we're going to use, because if we look at 21 degrees, right, this x right here, this is our hypotenuse, because it's across from that. And the only other information that we know is going to be the leg that is opposite 21 degrees. And because we only know the leg that is opposite, we're going to want to use sine, because sine is going to be opposite over hypotenuse. So the sine of 21 degrees is going to be equal to the opposite leg from 21 over the hypotenuse, which is equal to 1200 feet over x. So I'm going to rewrite this without this opposite hypotenuse in the middle. So the sine of 21 once again is equal to 1200 over x, and to get this solved for x, we need to multiply both sides by x right here. Those x's are going to cancel, and we're going to be left with x multiplied by the sine of 21 is equal to 1200. And now to once again isolate x, we need to divide both sides by the sine of 21. Those sines of 21 are going to cancel, and this is going to be x is equal to 1200 divided by the sine of 21. And you can go to Google and type this in, and 1200 divided by the sine of 21 is approximately going to be equal to 3,348.5